The same turbocharger plus direct injection. Why do some cars need 95, while others only need 92? In fact, it all comes down to their different compression ratios. Today, we will explain in detail the difference between 92 gasoline and 95 gasoline in a way that even car novices can understand, as well as the working principle of the engine, the cause of knocking, and the role of compression ratio. Why do we need to distinguish which grade of gasoline to use? If you can read it patiently and in detail, you are half an engineer, boss. Please give me a thumbs up. Let's start talking about it. First, let's talk about the basics. Any object needs air to burn. The same is true for fuel. If you want the fuel to burn fully in the engine, there is an ideal air-fuel ratio, 14.7 to 1. To burn 1 kilogram of fuel, you need to mix 14.7 kilograms of air. And air also has a very important characteristic. That is, it will generate high temperature after being compressed. Here is the key point. Air will generate high temperature after being compressed. The operation of our engine can be divided into 4 cycles, also called 4-stroke cycle. The first stroke is to inhale. The intake valve will open. The piston moves downward. Like a needle, it sucks air into the cylinder. At the same time, the fuel injector will also suck the atomized fuel into the cylinder. When the piston reaches the bottom dead center position, it enters the second stroke compression. At this time, the intake valve is closed. A closed space is formed in the cylinder. The piston moves upward. The air in the cylinder and the atomized fuel are formed. The mixture is compressed to the top of the cylinder. When it is about to reach the top dead center position, the spark plug on the cylinder will ignite this small group of mixture. It should be noted that after the spark plug ignites the mixture, it is a small flame that slowly spreads to the entire mixture. When the mixture is completely ignited, the piston just reaches the top dead center position, which enters the third stroke. At this time, the mixture just starts to burn. The heat energy generated is the highest at this time. The expansion force is the greatest. This heat energy pushes the piston downward. This is when the power of the engine is generated, when the piston is pushed to the bottom dead center position. It enters the fourth stroke exhaust. At this time, the exhaust valve is opened, and the piston moves upwards, push the exhaust gas produced by the combustion of the mixture into the exhaust system from the exhaust valve. When the piston reaches the top dead center, it enters the intake stroke again, and the intake valve opens. The piston moves downward again to inhale. This cycle repeats. This is the basic principle of the operation of the engine cylinder. Now let's go back to the high temperature problem generated after the air is compressed. In the second stroke of the cylinder, the smaller the volume of the compressed mixture is, the higher the temperature is, and the more unstable and uncontrollable it is. After being ignited by the spark plug, this small flame may not slowly spread to the entire mixture, but may ignite in advance in places that have not yet spread. This will cause the cylinder to burn. The entire mixture is ignited in advance. As mentioned earlier, the spark plug ignites before the piston reaches the top dead center. It will ignite when the piston just reaches the top dead center. The mixture is completely ignited to produce the maximum thrust. However, if the mixture is completely ignited in advance and the piston has not reached the top dead center, there is still an upward force. The downward thrust comes after the mixture burns. At this time, the two forces will fight. Not only will the engine power decrease, but the piston will also be unbalanced due to the force of the two forces fighting, causing left and right shaking, vibration and knocking of the cylinder. This is the principle of knocking. This is not the most important point. If it takes 3 milliseconds from the spark plug to ignite completely, if the time for normal advance ignition is the same, then the engine's ECU can also delay the spark plug ignition time to avoid knocking. But the key point is that the mixture is unstable. The time of early ignition is uncontrollable. It is possible that it is ignited in 2 milliseconds this time, and 1 millisecond next time, and 3 milliseconds the next time. So the key point is that the time when the mixture is completely ignited is uncontrollable, to avoid engine knocking. There are 2 ways. The first is to reduce the engine's compression ratio, so that the mixture is not compressed so hard and the temperature is not so high. Then the time to ignite the mixture can be controlled. The second is to improve the stability of the fuel, so that it is not so easy to ignite and can withstand higher temperatures. Therefore, the gasoline grade 92 gasoline appeared. The stability is the worst, followed by 95. The highest is 98. The stability and anti-knock performance of gasoline are the most essential differences between them. Then someone may ask why Mazda's compression ratio is 14 to 1, which is higher than most engines. Why can it still use 92 gasoline? That's because it is a naturally aspirated engine. The turbocharger compresses the air first and then sends it into the engine. After entering the engine, it is compressed again. Take a turbocharged engine with a compression ratio of 10 to 1 as an example. If the effect of the turbocharger is a 50% boost, then the actual air unit inhaled by the cylinder is 15, and then it is compressed to 1. The actual compression ratio is 15 to 1. In comparison, Mazda's compression ratio is 10 to 1. The compression ratio is not that high. Then someone said that Honda's 1.5T Earth Dream also has direct injection and turbocharging. Why does it still use 92 gasoline? Because it uses a low inertia turbine and the turbo pressure is not high. Simply put, the turbocharger intervenes relatively early and the boost effect is only 30%. The overall compression ratio is actually not high, about 13:1. So 92 gasoline can also meet the requirements, as long as we see cars that use 95 gasoline. Most of them have a high compression ratio. And the turbocharger pressure is also relatively high. Of course, there are exceptions, such as the Ford EcoBoost series. If there are interested bosses, you can click to follow us first. We will talk about it in detail later.